assignment 34A, we have a particle moving along the x-axis. The velocity is given as v of t is equal to the sine of pi over 4t. And we also are given the initial condition that x is equal to 3 at time t equals 0. So in other words, x of 0 is equal to 3. And we want to know when is the particle moving to the left. Particle is moving to the left when its velocity is negative. Particle moves to the right when the velocity is positive, so we're interested when the velocity is negative. So we want to know when is the sine of pi over 4t going to be negative. All right, now the graphing calculator tells us this, but we also want to be able to kind of solve this out using our own knowledge of the trig chart. All right, now we know that the sine of x is equal to 0 when x is equal to 0 or pi or 2 pi or 3 pi or so on, 4 pi. Any multiple pi, sine of x is equal to 0. Right? So basically, what values of t, where t is between 0 and 8, would cause us to have 0 or pi or 2 pi or 3 pi inside there? And the answer is, well, if t is 0, then we have 0 times pi over 4, and the sine of 0 is 0. Right? If t is 4, well, then we have pi over 4 times 4, which simplifies to just pi, and at pi, sine is 0. And finally, at 8, because 8 divided by 4 is 2, so we have 2 pi, and sine is equal to 0 when we have a value of 2 pi. So we have 0 and 8 are endpoints, and also 4. So basically what we're looking at here is what's going on with the velocity function before and after 4. So you got to plug in a number that's less than 4, say 2. All right, so if we plug in 2, right, we have the sine of, I'll put over here, sine of pi over 4 times 2, which is equal to the sine of pi over 2, which our trig chart tells us is equal to 1. So it's a positive value. If the velocity is positive, that means it's moving to the right. We're interested in it's moving to the left. Guess what happens when we pick a number to the right of 4, say like 6 or something? Well, now we have the sine of pi over 4 times 6, which is the same thing as the sine, let me get this on the screen there, of 3 pi over 2, which is equal to negative 1. So we have negative values there. So basically we're talking about numbers to the right of 4. So when is the particle moving to the left? On the interval from 4 to 8. Write but do not evaluate an integral expression that gives the total distance traveled by the particle from time t equals 0 to t equals 4. Total distance is the integral from the left bound to the right bound of the absolute value of the velocity. Alright, so that is an acceptable answer, or if you prefer, since we know what the velocity formula is, you can have absolute value of sine of pi over 4 t dt. Either one of those would be acceptable. Part C, write but do not evaluate an integral expression that gives the net distance. Now net distance, it's okay for our velocity function to be negative and for us to count it as a negative value. With total distance, we want everything to be positive. Net distance, all right, 0 to 8, it's just our velocity function. No absolute value. So this works, or you could have integral from 0 to 8 of sine pi over 4 t dt. Either one of those works. Part D, find the acceleration of the particle. Okay, well, a of t, that's the derivative of v of t. So we have to derive our velocity function. So we want to derive the sine of pi over 4t. Right? We have the sine of an inner function, which means we're going to do the chain rule. So the chain rule says derive the outer, sine derives to cosine, keep the inner, so we have pi over 4t, and then multiply by the derivative of the inner function. And the derivative of pi over 4t is just pi over 4. Now pi over 4 can go at the very end, it can go out front of the c, but either way, that function is our acceleration. Is the speed of the particle increasing or decreasing at time t equals 3? Again, speed is increasing or decreasing. That depends on the sign of both the velocity and the acceleration at our particular values that we're interested in. So we need v of 3 and a of 3. v of 3 is going to be the sine of 3 pi over 4. because again, our velocity function was given way up here. We're replacing t with 3. So we have the sine of 3 pi over 4. Our trig chart tells us that this is a positive value. It's actually the square root of 2 over 2. A of 3, well, now we're plugging 3 into this function right here. So we have pi over 4 times the cosine of 3 pi over 4. And the cosine of 3 pi over 4 is actually negative square root of 2 over 2. So we have pi over 4 times negative square root of 2 over 2. Right? Now I don't know what that value is, but I know that it's less than 0. I know that the square root of 2 over 2 is greater than 0, so therefore our acceleration and velocity have different signs. So the speed is decreasing. All right, why? Because, oops, that's therefore. Because A of 3 is negative and V of 3 is positive. And last but not least, part F, find the position of the particle at time t equals 2. So when we want to find the new position, all right, that means that we take, so we want x of 2. Well, x of 2 equals the original position, which we said way back up here. The original position was 3. So we have 3 plus the integral from when the position was 3, which is times 0, to the position that we want, which is 2, of our velocity function, sine of pi over 4 t, dt. Okay, so we have the sign of an inner function, which means we're doing u substitution here. U is pi over 4t, which means du is pi over 4 dt. We have the dt, but we don't have the pi over 4. So we're going to toss the pi over 4 in, which means we need a 4 over pi out front. All right, and now it's time to take our antiderivative. All right, so we have 3 plus 4 over pi, and then we have, I guess we should rewrite it first. We have the sine of u du, and we have to change our bounds. We plug 0 in, we still get 0. We plug 2 in, we get pi over 2. Now it's time to take the antiderivative. So 3 plus 4 over pi, antiderivative of sine is negative cosine, so let's make this negative 4 over pi cosine of u, and that's being evaluated from 0 to pi over 2. Right, so what do we have? We have 3 plus, actually we're going to make it a minus because we're adding a negative, so 3 minus 4 over pi, and we plug in pi over 2, so that's cosine pi over 2, minus, now we plug in 0, cosine is 0. So cosine of pi over 2 from our trig chart, we know that is equal to 0. Cosine of 0 is 1. So we have 0 minus 1, or negative 1. So negative 4 over pi times negative 1 just turns it back to being positive. 3 plus 4 over pi.